right, here we go, and we're back. Let's go with number 11. So remember, if we want to find the polynomial. If these are the zeros, then that means x plus 3 was equal to 0, and x plus 4 was equal to 0, and x minus 4 was equal to 0. So our three factors. So I have x plus 3, x plus 4, and x minus 4. All right, since these two are like the same, it's plus 4 and minus 4, I'm going to choose to FOIL those two first, okay? Because that's what we're doing here. We're going to multiply all three of these things together. There's a reason why I'm doing this. I get x squared plus 4x minus 4x minus 16. Well, look what happens with the 4x's. They both cancel out. So I get x squared minus 16. And I still have that x plus 3 that I have to bring down. And now I'm going to multiply these two. So this is why I chose to do that. Let's say you didn't. That's totally fine. Okay, if I chose to multiply x plus 3 and x plus 4, you would have gotten x squared plus 7x plus 12. And then you'd have to multiply x minus 4 to everything in there. Okay, so I'm going to multiply x plus 3 times x squared to get x to the third. X times x squared, x times negative 16 to get negative 16x. Here to get plus 3x squared, and there to get minus 48. So it should be a 48. All right, so our polynomial function, we want to write our powers in descending order to be x cubed plus 3x squared minus 16x minus 48. There, that's so bad. Got a battle. Here we go. Let's try the next one. Find a polynomial in standard form with the zeros of x equals negative 2i and negative 3i. Well, if negative 2i is a 0, then positive 2i is a 0. If negative 3i is a 0, then positive 3i is a 0. That means I have x plus 2i, x minus 2i, x plus 3i, and x minus 3i. So anytime this happens, anytime you're given an imaginary root, know that you're going to have two. That means I see an imaginary root, that means I have a positive and negative right away. That should go off in your head. All right, so I'm going to choose to FOIL these two together, and I'm going to choose to FOIL those two together. Okay? So here, I'll get x squared plus 2i x minus 2i x minus 4i squared. Well, these will cancel, and I'll get x squared minus 4i squared. Well, I squared is negative 1, so it's x squared minus 4 times negative 1. So really this comes out to be x squared plus 4. Okay? I squared is negative 1 because I is the square root of negative 1. So square root of negative 1 times square root of negative 1 is just negative 1. So I'm going to FOIL these two here. So I get x squared plus 3i x minus 3i x minus 9i squared. Again, our ix is canceled out to get x squared minus 9i squared. Remember again from right here that I squared is negative 1. You can obviously skip this part and go straight to the binomial. I'm just going to write it out because it's helpful for some people. So I get x squared plus 9. Now I'm not done, okay, because I actually want to multiply these two binomials together here. Okay, when I multiply these two binomials, just like FOILing, all right, except I have x squareds this time. So I have x to the 4th plus 9x squared plus 4x squared plus 36. So my final answer, if I combine my two like terms here, I get f of x equals x to the 4th plus 13 third plus 36. That's our polynomial. Wow, we're having so much fun. That's 2 problems down. Whew, we got some more to go. Wowee. Man alive. All right, the reason I gave you so many of these is just for extra practice, people. I mean, just extra practice. Obviously, you don't have to do all of them. If you understand what you're doing, then just go on to the next one. So I have x plus 3, x plus 5, and x plus 4. FOIL. I'm going to FOIL here. To get x squared plus 3x plus 5x plus 15. X squared plus 8x plus 15. Bring down the x plus 4. I want some more. I want some more. Now, I want to multiply x to everything in this parentheses here. So I get x times x squared to get x to the third. X times 8x to get plus 8x squared. X times 15 to get plus 15x. Now multiply 4 to everything. 4 times x squared, 4 times 8x, and 4 times 15. So plus 4x squared plus 32x plus 60. Notice how I line them up like this. I did that on purpose so that I could just go straight down to combine my like terms. All right, to get f of x equals x cubed plus 12 x squared plus 47x, right? Yeah, 47 plus 60. Wow. There it is. Isn't that neat? Let's make sure. All right, so let's do one that's a little trickier. So if x equals 1/2, x equals 1/2. Well, what I want to think about is I could do this as x equals 1/2, or I could create a binomial out of it, okay? And what I mean by that is I don't really want the fractions in here, so I want to undo the fractions. Well, how do I undo a fraction? First thing I have to undo is this divided by 2. So I'm going to multiply both sides by 2 to get 2x equals 1 here. And then I'm going to subtract 1 to get 2x minus 1 equals 0. So anytime you have a fraction here, make sure you write it out in a form that you are used to seeing, okay? We're not used to having x minus 1/2. We're used to having 2x minus 1. All right, if there's x equals 3i, then x equals negative 3i as well. So I'll have x plus 3i and x minus 3i. Remember, anytime you have imaginary numbers in your problem, that you should multiply those two binomials first. So I'm going to multiply these here, x squared plus 3ix minus 3ix minus 9i squared to get x squared. Remember, these cancel out. Minus 9i squared to get x squared plus 9. And this 2x minus 1 comes down. Now, next thing we need to do, FOIL it out here. 2x cubed plus 18x minus 1x squared minus 9 to get f of x equals 2x cubed minus 1x squared plus 18x minus 9. How about it? Let's keep going. All right, so now we're going to change gears, and we're going to go from the polynomial to the zeros. Okay, so now our goal is to find our zeros instead. All right, to find zeros of a polynomial. Well, if I have 4 terms, I want to try factor by grouping right away. All right, so what I mean is group the first 2, group the second 2. Well, I want to find the greatest common factor between our first 2 terms. I get x squared. What's left over inside? X plus 5. Find the greatest common factor between negative 3x and negative 15. Oh, I got negative 3 to get x plus 5 again. And this is equal to 0. Well, look, x plus 5 and x plus 5, so that means x plus 5 is one of my factors. And then I take the x plus 5's out to get x squared minus 3. And this is equal to 0. Now we're not done. I have to set each factor equal to 0. So x plus 5 equals 0. So x equals negative 5. There's 1 0. X squared minus 3 equals 0. So x squared equals 3. Square root. So x equals plus or minus root 3. How many zeros do I have? I have 1, 2, 3. Started off with an x cubed. That's a good thing. Beautiful thing. I should have 3 zeros. 1, 2, 3. There are my zeros. Wow. 3 more left. Hopefully I can get it done in 5 minutes. I doubt it though. So here we go. Group it. 2 by 2 grouping. What can I take out? I can take out an x squared. What's left over? X plus 3. What can I take out a second 2? I can take a 4 out. What's left over? X plus 3. And this is equal to 0. So I can take x plus 3 appears twice, so x plus 3 is one of my factors. Take out the x plus 3, I have x squared plus 4 left over, still equal to 0. Completely factored, set each factor equal to 0, and solve. X squared equals negative 4, square root, whoa! Taking the square root of a negative, I'll get x equals plus or minus 2. Well, if it's a negative 4, that makes it 2i. There are my 3 roots, or 3 zeros, excuse me. I'm going to save these last two since they're the same type of problem for the next video. Alright?